While you're getting settled, we do have one new concept that we're doing today. It's on page 5 of your booklet, but the majority of today will be spent in review, particularly of geometry, but also anything else that you still have questions about. So if you do have questions, feel free to find those, pull those open, and then we'll work on those after we get our final concept for today done. Oh, that's where the sound's coming from. Usually we can't hear the other room so well, so I was confused. All right, so again, we're on page 5. This is dealing with the trigonometric functions as a graph or a sine function. Most of you, if you're in this class, have done that before, but you have to remember that the ACT has this balancing act of difficulty versus everyone in high school should have seen this. And so they are going to throw trig functions at you, but the level that they throw at you, they are going for scary but doable. They're using this as a weeding function of, okay, this person really knows versus this person, maybe they've seen it before, but they just didn't quite understand. But again, because of that 60-minute time limit, everything should be very doable. And so if you're intimidated in any way, take a guess, move on, come back to it. So this one has this big setup of the function of y equals 2 sine 8 pi x, and it's graphed below. How many x-intercepts does the graph of this function have on the interval from 0 to 1? Does knowing anything about sine functions matter at all? No. What do you have to do?
Just count them.
Just count them. Don't get intimidated by it. There are sine functions that show up, but don't be overwhelmed. The biggest thing that you need to know beyond just count them is to remember it's asking for the interval with strictly less than greater than, and so we're not counting the two ends. Beyond that, it is literally tap the paper and count how many. There are 1, 2, 3, 4, 5, 6, 7. You don't need to know anything about this function. You don't have to calculate anything at all. They gave you the graph. All you have to do is count them. So half the time when you encounter a sine function at all on the ACT, it's kind of a scare tactic. It's just checking, do you feel confident with these, or are you going to skip it out of, I don't know. So that one was from the middle of the test. I believe it was problem 33, if I remember correctly. Yeah, 33. This one is a 59. This is from the end of the test. So, big block of text. I wouldn't have done this if I hadn't had the opportunity to start the class with it, because the amount of writing this out, it's just a lot. But give it your best guess. And for people online, I will read it aloud. It says, consider the family of functions where y is the function of x and it equals sine x plus c, where c is a real number. So we're dealing with a variable in the equation. It could change any which way, but we just know it's a real number. And which number line, there are 5 of them below, represents the graph of all the possible values of c, for which the graph of y has no y-intercepts. So it's asking, we've got this sine function. We know that it's a normal parent sine function, but it's having this number added on at the end. And it wants to know what are the possible values of the number being added on that would cause the graph to not have x-intercepts. and it wants you to graph all of those possibilities on a number line. Go ahead and erase out this one. So not a lot of scribbling. Does that mean you have an answer or you're lost? Answer? Okay. Oh, another person coming in late. How about for online? Answer or lost? They're shy today. So, this is a sign function question, but to me more than anything, this is the fundamental Algebra 2 question. Because in reality, it's not so much asking about the sign equation itself as the idea of parent functions and transformations. By adding a number on the end after the operation of a function, what does it do to that function? How does it change that function?
Up or down.
Up or down. So, the basic, very plain sign function is called a wave, and it goes like this. And most importantly, it's going to repeat itself every 2 pi, or 360 degrees, depending on which mode you're in or which method of measurement you're doing. And what's called the amplitude, or how high and low it goes, varies between +1 to -1. And again, hoping that you've done that before. So, in order to move this graph down far enough to not be crossing the x-axis at all, this point would have to move below 1, or below 0. It would have to move a distance of 1. It could move that distance in the negative direction if we moved it down, or it could move that distance in the +1 if we moved it up. So this one is out. Less than 1, very much out. This works, but it's not enough. We have to consider the both directions, and we can't include 1, because if we include 1, it's still touching just barely, and so we've got to have the greater than 1 or less than -1. Move it more than the unit of 1. Again, seeing it as a sign function, fairly rare. I did my survey of all my questions as I was cutting things out for this book. I see a sign function maybe once every 4 tests. And so, very real that it could be on yours, but not going to be a huge majority of what you do. Versus geometry, which we're doing next. Geometry's got its fingerprints everywhere. But this idea of the parent function and how it transforms, that one is going to be on every single test. There's going to be some sort of understanding of, if I change it here, it moves left or right. If I change it here, it moves up or down. The idea that negatives flip things upside down. All of those things, very much on there. So, I will look at that. Before I get to my stuff, is there any questions that you have and would like to go over, whether from homework, previous review, anything in the math section?
What tier question would this be on in the test?
This one right here, with
Yes.
okay, this was a question 59, so that is very much a high level conceptual question. How does this work?
Okay.
The one with the intercepts was right in the middle. Again, it was designed to, if you understand what it's asking, it's not difficult at all. If you don't know what it is, it's honestly designed to rattle you, which sounds like a horrible thing. As a teacher, I don't like that. But as a test to test people's understanding and knowledge, it does a really good job at separating, okay, these are people who are not intimidated by this versus these are people who are going to give up the instant they look at it. And that is its purpose, as horrible as that sounds. Again, as a teacher, I don't like the gotcha, but as the ACT, I understand why they did it. All right. In keeping with the trigonometry at first, lots of words again. I'm not going to write all of them because then you'd just be staring at me right on the board forever and that's no fun. But at a certain point, the angle of elevation formed by the level ground and the line from that point to the top of the Eiffel Tower, we'll test my art skills. Cute Eiffel Tower, is 70 degrees. So we've got a point over here, we've got a line from that point to the Eiffel Tower, angle of elevation, 70 degrees. They have not given us the drawing, but it's easier than trying to write all the words. Which of the following expressions equals the distance in meters between that point and the center of the base? That's interesting. I copied the question, but I didn't read it far enough. This is a mistake. Yeek. No, I'll show you guys online, but that question is not answerable in its given form. They're giving you numbers, but they're using a 320 that is never given to you in the question. And without knowing where that 320 is on the circle, it's actually not possible to answer. So, if it was as blatant as that, I would guess a letter, move on, but you can also lodge a complaint with the testing center. If you say, there was this question, number blank, that I think needs to be reviewed, I don't think it's possible. So again, mistakes happen. Honestly, I just grabbed that one as a sine trigonometry question and added it, but we'll have to look into that. It's not what I wanted to do, but that's interesting. So yeah, that ups my count of ACT mistakes I found to 2. Done a lot of these problems, but let's go for something simpler. Same category, we're dealing with the coordinate plane, sine, cosine, tangent, but we have coordinate axis, we have the angle of theta, and we have a point at 4, -3. And the question is, what is the cosine of theta? cosine is going to be trig or trigonometry. What shape are we dealing with trigonometry?
Right angle triangles.
Yeah, trig means triangles, specifically right angle triangles. And so we are dealing with a triangle. What dimensions do we know about this triangle?
The x and the y.
Yeah, we know the x and the y. The x is the horizontal distance. This is 4. This is -3 or down 3. So triangle, there's a 4 and a 3. What does your brain need to fill in? This is on my short list of things that I absolutely want you to remember that I taught you, if nothing else. There's a 3, there's a 4. What was it?
5.
5. 3 and 4. There's always 5. That Pythagorean triple is guaranteed to be on your test. And I want you to think of me for 2 seconds and then get back to testing. But that Pythagorean triple is going to be on your test. It's always there. If it's not there, you can track me down and I will bake you a cookie. But 3, 4, 5 is there. So the other thing to be aware of is we're talking about this angle. It doesn't matter. It's the same as this angle. So now that we know the angle, we know 3, 4, 5, what is the cosine of our theta?
Four over pi.
Yep, we have our adjacent 4 over our hypotenuse 5. None of those steps are particularly difficult on their own. The assembling them together in your brain can be a little bit tricky. That one is a 48 on the test, so it's getting kind of close to the end, but still pretty doable. So again, there's 3 and there's 4. Knowing that you can put those in the sides from the coordinates, that's something that they might hide those triangles within. Being able to match 3, 4, okay, 5 is going to be my hypotenuse, also good. And then the idea that this angle is the same as that, those would be the 3 concepts that you need to know in order to solve this particular problem. All right, again, sticking with the trig, but stepping away from the coordinate plane. Now we've just got a circle. Yeah, that's not bad. Our center is at D. We have a radius to point A. We have a radius to point C. And then we have a distance right here to point B. So we've got a right triangle drawn within an angle. The information that they've given us is that this is the distance 1, this is the distance 4, or the radius of 4, and they asked us to find the arc measure. From A to C. That's a horrible A, so I will erase that back. We're looking the arc measure, or the arc length, from A to C. They are writing it as an expression of trigonometry, so they're not truly asking you to solve it, but they are asking you to find it. And so it's going to be in terms of sine or cosine. How could we solve this? kind of as a sub-problem, if you had this set up where you were told that the angle was 20 degrees and the radius was 4, could you find the arc measure from x to y? Do you know how to do that? What's going on is that the total distance around the circle, or the circumference of the circle, is going to be diameter times pi, or 2 pi r. As long as you're comfortable with either one of those, they can work. But our radius is going to be 4, so our diameter would be 8 pi, or you could do 2, 4 pi. Either way, you're going to end up with 8 pi. So our circumference is 8 pi. But that's all the way around. And so in order to find out just this little bit of it, we would be comparing what fraction of the circle do we have. And so we have 20 degrees out of the distance around the whole circle, or the degree measure around the whole circle would be 360. And so that's the fraction of the circle that we have. It'd be 1/18 of that circle. And so we would end up taking 8 pi times 1/18, or 8 pi over 18 would work out to 4 pi over 9. So on this problem, we've added one more wrinkle. We don't know what this is. We just know, okay, my circumference is still going to be the 8 pi, because my diameter would still be 8. My radius is still 4. So I'm going to have the 8 pi, but I'm multiplying by this angle over 360. And that angle, we could talk about the sine of the angle. I'm going to use theta. That sine of theta is equal to opposite over hypotenuse, 1/4. And so the angle itself is the sine inverse of the 1/4. That's my angle. It's not in degrees, it's okay. We leave it in this form. And so we're going to have pi over 8 times the sine inverse of 1/4 all over 360. And then the 8 and 360 can be reduced down, and that's our final answer. So since you guys seem to like my number notation, that is also a 58. That is very, very near the end of the test. I would expect something like this, more likely, more towards the middle. The adding the trigonometry to it adds a layer of complexity, but the idea that the fraction of the circle is the ratio of what your degree measure is to the whole thing, that one's pretty common, and it's a more commonly done problem than just find the circumference of the circle. Finding the arc of the circle. That one, mid-level question I would expect. Adding the trig to it, that's a little bit extra. Might show up, but it's a higher level end of test type question. Another circle problem. the circle. I like that circle, so I'm going to trace it back. But this time, we have the radius to O in the center. We have A as a point. We have a tangent segment, meaning we have the right angle there. The right angle was drawn in the original picture, so you don't have to know tangents are at right angles, but they are. We have a distance of 12, a degree measure of 20. Oh, that's interesting. We've got 20 again. This is point P. And then point B is also laying on the circle. They give you the sine measurements. They tell you that sine of 20 is approximately equal to 0.342. Cosine of 20 is approximately equal to 0.940. And tangent of 20 is approximately equal to 0.364. So that's part of our setup as well. You are more than allowed to use your value of sine, cosine, or tangent in your calculator. When you see these, I want you to know two things. One is that it means you're going to be getting an exact answer rather than sine, cosine, tangent included in your answer. When they give the decimal approximations, you are finding an approximate answer. You're not trying to write it as sine, cosine, or tangent. So when you see those numbers, that's the one thing that I want you to take away from it. The other one is that you can type sine 20 into your calculator really fast and see if you get that decimal. It's one of the fastest ways to check, is my calculator in the right mode? Your calculator should be in decimal mode for the ACT. If it's in radians, it'll mess it up and just cause havoc. And so especially when they give those numbers, it's a really easy to check. Say, does my calculator agree? So that is something to be aware of if you see this type of problem. So finally, you are asked to find the distance from P to B. Your hint is that you should find the radius. right. So I gave the hint that we should find the radius. What is the radius?
12 times tangent.
Okay, so you acknowledge this is the opposite. We know the adjacent, so I agree to tangent. So the tangent of 20 is equal to opposite over adjacent. So I'm going to call my opposite just O, and then you multiply to find it. Good. What did you get?
4.367.
Okay, 4.367. It's best to give yourself extra decimals until the very end, and then you can round to whatever you need to for the answer, but give yourself that buffer. All right, how did you go about this next? What should we do next?
Find the length of OP.
Yeah, we're looking for our hypotenuse. Great. Personal preference, I've had people who really like the Pythagorean theorem, and so the instant they know these two, they're going to dive right into that to find the hypotenuse. There are some people who are saying this is a trig problem, I'm sticking with trig, I should find the hypotenuse using trig. The one thing that I will say to that is, as much as possible, stick with the numbers they originally gave you, rather than trying to use this decimal, because the chance of compounding errors is just enough there that it's better to stick with what we've got. So in order to do that, I would be using the cosine, because I have my angle and this is adjacent to it. And so I'd be looking at the cosine of 20 equals my adjacent 12 over my hypotenuse that I'm looking for. Everybody comfortable with how to get a variable out of the bottom of a fraction? Trade it out. And so we have 12 divided by the cosine of 20. What did you get?
12.77.
12.77? All right, is that my final answer? No, we need to be subtracting out our radius so that we can find just this length. So we're going to take out 12.77 and subtract our 4.37, which would leave 8.4 roughly. So the circle has very little to do with it until the end, knowing that this radius is the same on both lengths. Other than that, it's a fairly straightforward trig problem. All right. I know I've done geometry with you before, but I struggle to remember what I've done or not done, so I'm gonna pull open a couple problems, and if they are stuff that you have already seen, we'll go to the book hunting for more examples. All right. I'm gonna sneeze. Excuse me. So we have three lines crossing each other, all at the same point. We are told that line N is perpendicular to line M. And so these two lines are crossing at a right angle. We are also told that both lines intersect Q at the same point. Again, that's less important because they do provide the drawing. And they give us the angle numbers of 1, 2, and 3. Now we're switching into algebra. The measure of angle 1 is 3x minus 10. The measure of angle 2 is 2x plus 10. And we're asked to find what is the measure of angle 3. This is a problem 46 on the test, so again, moderate difficulty, but doable. All right, what is the first geometry concept we need to know in order to set this problem up?
Equal measure 1 and 2.
Yeah, vertical angles are congruent. It gets a little bit messy when we've got more drawings going on. It's easier to see if they were the only two angles there. I call them the bow ties. Two angles exactly opposite each other are congruent. So 1 and 2 are exactly opposite each other. 1 and 2 are congruent or equal to each other. And so back into the algebra solving, that tells us that 3x minus 10 is equal to 2x plus 10. Solving very, very simple here. Every x except 1 cancels out, and so we have just x. Add to the 10 over x equals 20. But with that 20, what next?
Plug in.
Plug in. You can plug it into angle 1 or angle 2. Just for my mental thing, it seems to make more sense to plug it into 2. Just how I see it. So 20 times 2 is 40, plus 10, 50. Where do we go next?
Add 90 and subtract 100.
Yes. Little bit of a long route, but it works. So he wants to add this 90 in and acknowledge that the straight angle makes 180. And that is true. 90 plus 50 would be 140. 140 taken from 180 is also 40. Geometric concept that you can use marginally faster, but not enough to change your thinking if that's the way you see it. It is mere seconds different. But if this is 90, this is also 90. And so if this is 50, that's 40. So again, as long as you got the right answer, it's milliseconds difference. All right. Again, this was a 46, so about medium level in geometry. Not bad, just multiple pieces. And really that's a lot of the ACT. There's frequently it's one answer, but it's going to take 3 different steps of geometry and algebra shaken up together. All right. We have a triangle. We have lines extending beyond in order to create angles. And we have a line crossing through. We have angle A, C, D. We have a right angle. We have a right angle. We have 132. And we have described below, it says in the figure below, A is on line BE and C is on line BD. Oh, I forgot to write in B, no wonder. There. What is the measure of ABC? This is problem 19 on a test, so relatively near the beginning. All right. So, again, with geometry, there's a couple different ways to get this. Which one makes most sense to you? I'm going to label these angles as 1, 2, 3, and 4. These are the tools that we can use. If you remember it, there is a theorem or a property in geometry called the exterior angle theorem, or exterior angle sum theorem, and that says that 3 and 4 together are going to add up to this exterior angle, and so 90 plus angle 4 is going to equal the 132. That's the shortest method, but it comes at the cost of maybe you don't remember that one. It's one of the ones that is most frequently forgotten. I remember it because I've taught it several times, but as a student I did not hold on to it very well. And so in your case, if you do not remember that or you do not see that, the backdoor still fast enough, still good enough method is to go back to, what's a straight line? We just used it.
180.
180. So if this is 132, what's this?
48.
180 minus 132, 48. And the triangle itself also equals 180. Triangle angles add up to 180, and so we have 48 plus 90 plus angle 4 equals 180, and you can solve that from there. You can see where this one comes from, because if we subtract just the 48, we're right back to this problem. But if you do not remember exterior angle sum, you can still use linear pair and triangles add up to 180. So this one, shortcut, don't know, you need to know it. Linear pair and triangles add up to 180, that one I would definitely know. There's always going to be a linear pair question somewhere. There's greater than half chance that you have triangles add up to 180 somewhere on your test. So those are the two properties that I would keep in your brain. All right. have a goofy looking quadrilateral. The measure of angle C right here is 90. And we are told the side lengths of 3, 4, 13, and 12. Finally, they ask you, what is the tangent of angle A? Please do not hold my bad drawing skills against me. It is not to scale. Correcting for my bad drawing skills, that's better. So, again, right triangles all over the place. 3, 4, how long is that one? 5. 5, 12, 13 is another Pythagorean triple. It's not as well known, but if we take 5 squared plus 12 squared, it will equal 13 squared. 25 plus 144 equals 169. And so this is also a right triangle. That's the background. So now if we need the tangent of A, it's just going to be 5 over 12. So, not terrible, but it hides that solving within it. Again, if you see 3 and a 4 in a right angle, fill in that 5. It's going to show up. And then from there, you can talk about, okay, I've got this triangle, can I make it a right triangle? If it weren't a right triangle, you'd be looking at that law of cosines that we talked about last week, but that would be a higher than level 44 problem. That would be like a tail end of test problem, and they would have given you the law of cosines to work with. So we can assume it works out to a nice pretty right triangle just because of the structure of test. All right, time for one more, and then I will let you go to break. So, geometry as a class versus geometry on the ACT is very different. Geometry as a class is very logic heavy. If you had a teacher that was enthusiastic about proofs, you probably did some proofs. But it has to do with that building a logical argument or logical thinking. So, the final question says, when considering the changing triangle formed by A, B, and the moving airplane C. So we've got point A on the ground, point B on the ground, and there is an airplane. We will not criticize my drawing skills. There's an airplane flying above the ground. And so that airplane might be here, but it could also be here or here, because it is flying above our drawing. And says, which of the angle below increases in measure as the airplane flies due west beyond the point directly above A? So, I think I've got my airplane turned upside down. Or not upside down, turned backwards. Because it says directly above A, and it's flying west. So, angle A, angle B, angle C. As our airplane flies, it's going to go this direction. Is angle A going to get bigger compared to where we started? Yes. Is angle B going to get bigger? Is angle C going to get bigger? And that is our answer. Angle A only, the first one only. And so they did not give you a picture, but I would definitely recommend drawing a picture, because it's not necessarily my drawings are the only two cases, but it allows you to see what's going on. And again, your airplane does not have to be beautiful. It could be a dot called plane, P for plane. All right, go ahead and take a 5-minute break, and we will trade teachers.